Morning everyone, hope you all had a good weekend and you're raring to go for another week of work. I know it's probably getting a bit hard now that we're into June, but we're really impressed with the work that you're doing in school, so just keep it up. Mrs. Bingham has made for us 3 lessons about bonding, which is going to help those of you that have picked to do GCSE chemistry, double award, single award or BTEC next year, because it's a topic that comes up in all of those subjects, and we thought it'd be worthwhile to have a little introduction to it and get used to it. So it says here in the page, introduction to bonding, it's about how atoms join together. So you know from the periodic table what our atoms are. You've been learning about the structure of the atoms, and we know where the metals and the non-metals etc are in the periodic table. I want to talk about, I'm just going to introduce to you about how these are bonded together, and then over the next 3 lessons you're going to be learning about the different types of bonding. So I'm going to start by showing you 2 things. I'm going to try and pour them out onto my folder here so you can see them. So this is some salt, and then if I get the spoon, this is some sugar. Now I'm sure you have these in your house yourself. They look quite similar, don't they? Just looking at them. You can zoom in a wee bit whenever you're at home and have a look, get a clear picture. But I want you to imagine that we have a super microscope that we can look and see what the atoms are. And I suppose people sometimes think bonding is confusing because you can't actually see the atoms. But imagine if we were to zoom in and look at them. So we're going to talk about salt first of all. Some of you might know what the chemical name for salt is. You might already, can you guess? You might know that it's sodium chloride. Some of you might be able to tell me that the formula of it is NaCl. Okay, and this, I've made like a little model. Now in school we have the actual molecules that we can make these models with. I had to improvise a wee bit at home. So this is showing us how the sodiums and the chlorines join together to form a salt crystal. Now in the actual crystals, you can't really see it there in the white page, but in the actual crystals there's thousands and thousands, maybe millions of atoms joined together. This is just a little example of what it would look like. So you will probably see from the formula that this is between a metal and a non-metal. So in our periodic table, sodium is a metal and chlorine is a non-metal. And bonding, or how atoms join together, it's all to do with electrons. Electrons are key to this. So in this example, the electrons move from the sodium loses electrons and the chlorine gains the electrons, and they become what's called ions. And this type of bonding between a metal and a non-metal is called ionic bonding. I wonder, have you heard of ionic bonding before? Some other examples that you maybe bet but not realise they're ionic bonding is magnesium oxide. So when you burn magnesium in the lab, you create magnesium oxide, and copper chloride. But there are hundreds of ionic compounds out there as well. But the key is that they're between a metal and a non-metal, and that the electrons move. Okay, that's what ionic bonding is. So now if we look at the sugar, so looking at it appearance wise, it looks quite similar to the salt. It's still white, it's still a crystal. But the way the atoms are joined together in sugar molecule is totally different than the way they're joined together in salt. So there are different types of sugar. Today I'm just going to talk about one type. I'm going to talk about glucose. Now you may or may not know that the formula for glucose is C6H12O6. And looking at your periodic table, you will see that carbon, hydrogen and oxygen are all non-metals. You should also remember from our work in year 10 that that formula contains 6 atoms of carbon, 12 atoms of hydrogen and 6 oxygen. Now, how those are joined are quite similar to this. This is the best I could do with jelly tots and cocktail sticks. But whenever you're back in school, you can get your chemistry teacher to show you what it looks like using actual molecules that we have in school. But if you want to pause the video, you can check that what I've built is the same as the formula. So we should have 6 carbon atoms, which are the purple jelly dots. We should have 12 hydrogens, which are the yellow ones. And we should have 6 oxygens, which are the red ones. And how they're joined is by what's called a covalent bond. So it's covalent bonding for the sugar. And how that works, remember we said it was all about electrons. So in a covalent bond, the electrons are shared. So the 2 non-metal atoms share electrons to get a full outer shell, You remember in the ionic one with salt, they gave away the electrons, and one gave away and one gained, whereas in covalent they both share. And this the lesson that Mrs. Bingham has done about covalent, you'll learn a wee bit more about that. So just to remind us, it's between non-metals. And some other examples that you'll have heard of before that contain covalent bonding are water, oxygen and carbon dioxide. They're examples of covalent bonded molecules. Okay, so the last one we're going to talk about are metals. Now, we're not going to spend a lot of time doing this year. We're going to leave this until year 11. But I want to just introduce it to you and talk a wee bit about it. So, you're all familiar with what metals look like. There's different types of metals out there. There's loads of metal atoms in the periodic table. But they are just made of atoms. So, I had to try and make up a wee makeshift thing of this. Now, I don't know if you can notice or not. There are 2 layers of mint poppets in here, and if I start to add a third layer, then you keep adding them until they all fit in together. And that's how the metal atoms are arranged. They're arranged in layers, and they're all the same. So they're all the same atom. They're all, like, if we were making iron, they would all be iron atoms, all arranged in layers. So the atoms are arranged in layers. That means that the metals can be slide over each other, and they can be made into different shapes. But once the tricky bit, or the bit about bonding, remember we said it was all about I said it was all about electrons. When the atoms are in the layers, they become ions. Now, you will learn about what ions are when you're doing about ionic bonding, when the atom loses an ion. So they become ions, and they're held really tightly together, which is why metals have a really high melting point. So in the metallic bonding then, the electrons are what's called delocalized, and we'll learn lots more about this in year 11. So hopefully that's been a good little introduction to you, and you have an idea of what you're going to be studying. I want to thank Mrs. Bingham for all the work that she put into making these lessons, and hopefully you enjoy them, and hopefully it gives you a little bit of an insight into what you'll be learning next year in the bonding topic, and I'll give you a bit of a head start when you come to it, when you're doing either GCSE Chemistry, double award, BTEC or single award. Okay, good luck.